Now it's time to talk about networking. So here I have my Mac open in this terminal, and in this terminal I've got an Ubuntu Linux machine that I'm logged into. So both of them, Mac and Linux, are almost identical in a lot of respects. They both use almost the same commands for everything. So ifconfig on Mac has a little bit different output than ifconfig on Linux does, but they're both they serve the same purpose. So here there's EN0 and EN1, which happen to represent my hardwired Ethernet and my Wi-Fi. And you can see right here that I am connected on the hardwire. And then likewise on Ubuntu, ETH0, ETH1, and WLAN, anything that's prefixed with ETH or WLAN are the interfaces. And so here is the IP address. So you'll notice that in Linux it's called INET-ADDR, and then on Mac it's just called INET. Okay, so what I'm going to show you, I have not set up a firewall on my Mac or on Linux. So if I just do ping, and what was the address? 10.0.0.115, I should be able to reach that. Yep, I can. And in fact, I could do ping-c1 to tell it just do one packet. Okay, and then let me go back to here. 118. Okay. So I will ping-c1 192.168. No, that was 10. 10.0.0.118. Okay, good. Now, an IP address is kind of like a phone number or a street address. It doesn't necessarily represent a physical location, although when you get into these lower octets, each of these I think is called an octet, there's always 4 numbers separated by dots, and the numbers can go between 0 and 255, and the smaller ones normally represent computers that are in the same geographical area, or at least that are connected to the same router. And then the next number up is usually connected to the same router, and the next number up and the next number up. There are some exceptions to that, but that's advanced networking, so we don't need to get into it. But just suffice it to say that this is how computers find each other. Okay. Now, also, I think on here, I may actually be able to tell it to ping. The name of this laptop is Boss. Yeah, so that works too. Cool. And I don't know if it'll work the other way around. Yep, it does. Great. So there's a program called MDNS that for computers on your same network, like your phone, your printer, your laptop, etc., whatever the name of the computer is, which on mine it says the name of the computer right here. On your system it'll be different because you'll probably have a different setup than I do. The way this is displayed is completely arbitrary, but here on my Linux box it says my username at the machine I'm at, and then same thing here on my Mac. And so when I do that name.local, it can do some magic to figure out on the local network what the computers are, just like if I were to ping google.com, it can look up on the internet what the address of google.com is. So what I'm trying to demonstrate here is just 2 computers, this one that I'm logged into, this one that I'm actually on, and we're able to see whether or not they can talk to each other. Because if you can ping the other computer, then then you know that they can see each other on the network. If you can't ping them, there could be a firewall or something preventing that. So you don't know for sure that they can't see each other. But if you can ping, then you do know for sure that they can. So I was going to talk about local networks a little bit. You'll notice that these addresses start with 10. Local networks always start with either 10 172, 169, 192, or 127. So those numbers, let me just get something up here. 10, 192.168.x.y.z.x.y, 172, I don't remember if there's another number that follows that or not, and then 169 and 127. So let me just explain these real quick. Basically, the router that you buy for your home is always going to have a 192.168 address, almost always. There's a few that use the 10 address. I don't think I've ever seen one that used the 172 address. And some of the routers, particularly Apple, I know uses 10. 172, I don't know what uses that, like I said. 169 is when there's no router present or there's no device that can give addresses on a network. Then a computer will just pick at random an address in this range. So that's not used for internet. And again, these are not used for internet. So these are what we would call intranet or private or NAT addresses. There we go. This is self-assigned, and this is localhost. Now, I don't know the specifics of all the 127 addresses, but I do know that 127.0.0.1 always means my own computer. So if I ping 127.0.0.1 here, it reaches this computer that I'm on. If I ping it here, it reaches this computer that I'm on. That's also called localhost. So there's always a computer named localhost for every computer, which is that computer. Just like I refer to myself as me, all computers refer to themselves as localhost. Right? Okay. So that's the tightest network group. The next step above that is the intranet group. So the intranet group, again, these are not unique. So there are lots of computers that have the address, for example, 192.168.0.1 or .100. There's lots of computers that have that address all around the world because they're connected into a network that is a private network or a NATed network, an intranet, not the internet, that gives them that address. And then these computers can, of course, access the internet, but the internet cannot access the intranet. Okay? Self-assigned is an intranet. These are given by routers. Self-assigned are not given by routers. They are given by the computer itself. So I think that covers the basics of the IP address. So just what it looks like and that it stands for an addressing system. Next topic. Now I'm going to show you how to open a connection to another computer. So again, here is my Mac, here is my Linux machine, logged into my Linux machine, actually using my Mac. There's a utility called Netcat, which is abbreviated as NC. And if you want to look at the documentation for it, you can type man NC. It will bring up the documentation. You can scroll through it, hit Q to quit out. So I'm going to open up a listener on port 4000. So the listener is going to listen on all addresses that my Mac will respond to. That includes localhost, which is the 127.0.0.1. It includes the IP address that has been assigned to it. I should probably make note of what those IP addresses were. I think it was 10.0.0.115, 10.0.0.118. I don't recall which is which. No matter. So it'll listen on any address and respond to any address as long as it's on port 4000. And port 4000 is kind of like a door, basically, into the computer's networking. Just like you can have a house, but you can have many doors, many ways to get in or out. That's what a port is like. So I'll go ahead and start that listener. And then over here on my Linux machine, I'll use netcat and I'll give it the address of that machine, which I think was 115. And then the port to connect to, which is 4000. And that was wrong. Maybe it was 118. Yeah, okay. So my Mac is 118. Now that I've got this connection open, I can just type something. Hello, Ubuntu. Hello, Mac. Right? So this network connection is open, and what you're seeing going across the network is just the stuff that I typed. Because of the way that this program works, it waits until I've finished typing and I've hit enter until it actually sends the data across the network. But this is raw. This is exactly what's going across the network. These are exactly, the data gets bunched up, sent, and unbunched on the other side, and that's what it is. This is extremely basic. And to prove a point of just how basic this is, I'm going to use now my Linux machine as a web server. So I'm going to go ahead and hit Control-D. That sends basically the end of transmission, the end of line or end of file signal, which is a lot like the letter H, except it's one that you can't see. I could have just hit Control-C to cancel the program, and that would have worked as well. But anyway, now I'm going to open up 10.0.0. Oh, no. I'm going to listen on this one, again on port 4000. And I'm going to open up, let's see, where did Chrome go? Oh, there it is. 10.0.0.115 was the Linux machine on port 4000. So here you can see this is what HTTP looks like. This is what a browser sends. So it's not really all that crazy. It's just text that's going back and forth. Now I could send an image, perhaps. So to show that point, let me see if I can find a very small image. I'll look on Google for Google Images for a smiley real quick. And let's go with search tools, and let's go with smallest we'll find is probably 16 by 16. Let's go smaller. Let's go 4 by 4. It's probably impossible to put a smiley in that size. All right, exactly. Let's try 8 by 8. Maybe just try image. Nothing 8 by 8. Okay, we'll definitely be able to get 16 by 16 though. Okay. Actually, since we're here, Facebook logo is as good as any. Let me actually clarify that I want to do file type PNG. Okay, and view original image. There we go. So what I'm going to do now, I'm going to cancel this server. If I go back to where it was, you can see there was an error because the server didn't actually do any HTTP stuff. I just let the browser send stuff to me and then canceled on it. But what I'm going to do now is I'm just going to go ahead and download that image. And I think I can use dash, is it capital O? fb.png. Let's see if that worked. Yep, that's probably right. If I open it up, it looks like garbage, I'll know for sure. But I'm going to start this listener again. So just a TCP network listener. and then I'm going to connect to it from here. 10.0.0.118 was the other one. And then I'm going to use this director, this less than caret, and take that image, and I'm going to put that image over the network. Okay? Just so you can see what a file looks like when it comes over the network. Oh, I didn't specify the port. Port 4000. Did I get it wrong again? Was that 115? Yes, it was. Okay. So now this is crazy garbage, right? But this is what the image looks like. If I wanted to transfer this file from one computer to the other, and actually this would work much better if I go this direction. So I'm going to wget that image, fb.png, and download it. Oh, looks like when I pasted that in, some things got messed up. I need to surround it all in single quotes, that whole URL there. Okay. So now I have that image. I'm going to send it the other way. I'm going to again open up the listener on this side, just like I did before. Except I'm going to give it the image on this side is what it should send automatically. And then on this side, instead of sending, I'll say that I'll receive. So now I'm changing the way the caret goes. So instead of printing to the screen, it'll print to the file. And now if I open up that file, okay, did I type something wrong here? Let me just double check on this. All right, that looks like that's right. Oh, that's okay. That's right. I wonder why that didn't work the first time. But anyway, so I can see that I successfully transferred the image over the network. So this is just really, really simple networking here. I'm going to clear out both of these screens, and now I want to repeat that same process, but I want to use Node.js to do it. So I'm going to create a program called netcat.js, or maybe I'll just shorten it to nc.js, and I'm going to replicate some of the functionality of what we just saw. So I'm going to start off with the obligatory IFI, the immediately invoked function expression, which in Node.js you don't really have to do, but I always start it with all my JavaScript files just so that I have the same common convention, and that I could use them in the browser if I wanted to. Obviously this I wouldn't be able to use in the browser because I'm using Node's net module, but other files I do. Anyway, aside the point. So let's see, net. I need to know how to use net. So I'm going to go to nodejs.org. I'm going to click on the API docs, and then there's all of the core modules that Node has. And I'm interested in the net module because I happen to know that's what I'm interested in. And here's all the documentation for all the different methods that it has. It's very clear, very great examples in here. So I'll just go ahead and copy this example. No. I'll rewrite it just so that we can talk about it as we go through. So I'm going to put up this one. This is going to be the server. I'll write a server, then I'll go back and I'll write a client. I won't do it in the same program just for simplicity's sake right now. So server equals net.createServer. And that server needs to get a handler, handle client. So I'm going to handle client, and I'm going to receive in this function a socket or a client, whichever way you prefer to call it. And then I'm going to call server.listen, and I need to give it a port. I'll give it port 4000, and then I need to give it something when it actually begins listening successfully, a function to call. So I'll give it on listening, I'll call it. Great. function on listening. And that one I think might be able to take an error. I'm not really sure. It's very rare that you get errors on a listener. I think maybe you have to do a separate like server.on error for that. I'm not sure. Anyway, we're not going to have an error, so I'm not going to worry about it right now. And the only error that we'd have from starting the server is if there was already a server listening on that port, so we're good. Anyway, so socket, oh, let me first just do this. Console.log started listening on, and then just give it server.address. And if you go in the docs here, you can see that this is the function that returns the IP address and the port that the server is listening on. Oh, and my JSHint file does not exist right now. Let me put that back in place. In another one of my tutorials, I talk about JSHint and how to get it all set up. But for every file that I edit, my JSHint will show me what types of errors are in the file based on what my JSHint-RC has in it. Anyway, so I want to say on data, and then I'm just, instead of naming this function like I did with the other ones, I'm just going to include it in line. So on every time a client connects, that's this handler right here. When I create the server, every time a client connects, it calls this handler. So it creates a client or a socket, whichever way you prefer to call it. I think I'll actually just go back and call it client for clarity's sake. Some people would like to call it socket for clarity's sake. I guess it depends on what you're trying to clarify. But I'm getting back a binary chunk of the stuff that came over the network, and then I'm going to do something with that chunk. So in my case, I think I want to require nodes util module. Nah, I'll just keep it super simple for now. Console.log prints an extra new line, and the chunks that are coming across the network will always have already have a new line. So we'll just see 2 new lines instead of 1 like we did before when we were using just netcat. And then also, I guess when the client first connects, I'd like to see what the local, no, it's called remote address, I think. Remote address, yes. Oops, what happened? Remote address and client.remote port. Let's just start off with that right now. That's actually a pretty good start. I'll comment out these lines. And so all our server does is tell us that it's started, and then tells us when a client connects what the address of the client is. So we could even make this a little prettier maybe. Okay. And now let me just try my server and see if it runs. Okay, cool. So now my server is started. The address 0000 is another special address that just means every address. So it means it's listening on 127 and the 10.0.0.118 and so on and so forth. Then here I will run regular netcat, and I will connect to 10.0.0.118 on port 4000. And then I can see that the client connected, but I'm sending data and nothing's happening yet. So close and clear, close, and open this up. So now I'm going to, every time I get some data from the client, I'll just log it to the screen. That's this part that I just uncommented. So now I'm adding that to the program. Let me make this a little wider here. Save and quit. So :W, :Q. And then go back, do the same thing again. So if I printed out the message that the server's listening, it'll print out the message that the client connected. But now if I type hello Mac, I get back, actually this is the JavaScript, a node buffer object. So let me go in here and change that to string. Let's say I don't want you to tell me that you're a buffer. I want you to tell me what characters you represent. Okay. And again. And now you can see that my message was sent. And since I hit return, since I hit return, it sent one new line. And since I'm console.logging, it put the other new line. So that's why there's this extra space here. Now, what I'd like to do is have this reply back with the same data that it was given. So I'll have my client call write, which again, this is mentioned here. It's all called socket because from this perspective, whether it's a server or a client, it's still a socket, and so that's why they refer to them as sockets. Although there are some things that are specific to a server that are called server, and some things that are specific to a client, perhaps. Nope, I don't think so. Anyway, so all the documentation's there. That's all I wanted to point out. And then I'm just going to send back the chunk, whatever chunk was given to me. So now we have an echo server. So again, I'm going to connect and I'm going to say hello Mac, and then it repeats back to me on my own screen what I said. Now I want to change this program again. I want to make it so that when it disconnects, that it says something. Actually, this probably won't work because when it disconnects, it's not connected anymore. But I'll try it anyway. See if it works or not. Yeah. So I can't actually say goodbye because when I get the notification that the thing is disconnected, it's already disconnected. But here I could say client joined and client left. How odd. Oh, I guess because the remote doesn't exist anymore because it's already left, so it no longer has a remote address or a remote port because it's disconnected. So I could do this. I could do adder and port and assign adder here and assign port here. And then do the same thing here. That way, if it changes on the client itself, I still have a reference to what it originally was. I'm going to make this bigger again. Okay. Hello. So it tells me the client joined, the client left, and I can have multiple clients at the same time. So I'm going to open up another terminal just right here on my Mac, and oops, I'll make this one kind of small, and I'm just going to use Netcat and connect to localhost and on port 4000 and say hello from this one. And then if I wanted to make this into a chat server, all I would have to do is have a list of clients, and then every time any client gave data, I would just take the list of, well, anytime a client joined, let's see, I actually want to do it this way. So here we go. Already getting into a chat server. How awesome is that? So I'll just replace this with name. And then here I'll have clients name equals client. And then every time a client joins, we assign it to clients. And then every time a client leaves, we can assign null to it, or just delete it actually. And then every time one client writes to other clients, so now I'll get rid of this logging here. We'll just do clients.forEach and then pass in a function for what each should do. And oops, excuse me, that should be object.keys clients for each. And so that will return me the names. And then I'll have var other client equals client's name. Then I can say if client equals other client, just return, because there's no sense in really echoing back to itself. Otherwise, other client dot write name plus, do the arrow, plus chunk. So now I've turned this into a chat server where every time we get a new client, we add it to this hash of clients that's sorted by the name, which name is the address plus a colon plus the port. We say that a client joined. Then every time a client gives us data, we loop through the names of all the clients, and for each of the names, we access the client by its name and call it other client. If the other client is the original client, meaning if I'm the one speaking, then we just bail. But if I'm not the one speaking, then that message gets sent to me with the name, and then this is just for text formatting on the screen, and then what the message was. And then when a client leaves, we say that the client left. And now I can run this program here. Oh, no, ran the wrong one. I'll start my server, connect to it. We see that a client joined. Connect to it from here. We see that another client joined. And now I can say hello all, and then this received it. Right back at ya. And then this received it. So if I open up yet another terminal, and yet another client joins, we can see it hit both of these. Now keep in mind, this one is on another part of the network. Now if I had run this server on this program server on a server, meaning like if I had a machine that had access to the internet, then I would be able to open up these connections where everything on an intranet, remember, can access the internet. So I can run this server. In fact, I'll go ahead and do it. I will log into one of my machines. I think this one allows me to log in with just a password. Let's see. Cool, it does. All right. So let me open back up that file that I have here. I just use cat. There we go. Or, no, I'm not going to do that. Cancel that. I'm just going to do this exactly the way we've done it before. So I'm going to open up a listener. This time I'll open it on port 8000. Actually, first let me check my firewall. I think I've got port 8000 open. So I'll open up a listener on port 8000, and then I will direct the output of that listener to nc.js, and then here I will open up my server on port 8000, and I will hand it my program that I just made. Okay, maybe that didn't work. All right. That doesn't look like it worked. Okay, I'm going to go back to the copy-paste method. I don't feel like figuring out my firewall right now because that's not part of what I want to show. Alright, so :set paste. Go ahead and paste that in here. And now, okay, listening on port 4000. So now that server is on the real internet. So now any computer in the world can join this chat server with Netcat just by opening up thrustVPS.coolaj6.com on port 4000. Whoops, not what I wanted to do there. Whoa, too many things. Hello. Hey, I think there's the other one back here. And we can see all the different terminals are updating, and this server is actually on the internet, so I could call up a friend and tell him, hey, open up terminal, get on Netcat, join my chat, and they'd be able to do it. Okay, so that's how we do a server. I'm going to exit out of my server, so I'm back on my Mac again. Sorry for using the term server to mean two things here. One meaning a program that serves over a network, and the other meaning a computer that is on the internet, but that's the way it is. So now I'm going to do nc client.js and write the client side of netcat. So we'll try this in reverse, where I'll use the real netcat for the server and then use the client netcat as the client. So, and then maybe I'll show both the JavaScript netcat server and the JavaScript netcat client together. But again, var net equals require net and net.create connection, I believe it's called. And then I have to give it what I want to connect to. And I think the way that's specified is first port and then address. So I'm just going to have to hard code, as they say, the address for now. And instead of using magic numbers, I'll name these. Magic numbers is what some people refer to, or magic variables in general is what people call it when you just put a number somewhere in your code without ever defining what it means. So it's always better to actually name a variable, even if it's, you know, you're just hard coding something for a quick little hack. It's good to name your variable, so when you come back and look at it later, you're like, oh, okay, yeah, I remember what that means, just in case, you know, you forget exactly what it was you were doing, which happens all the time. So let's see. I think the way this one works is client equals, and since here we're not handling multiple servers, there's just one server. There's one, or you could also call it the host. It's the thing that's hosting the party, right? And servers are commonly referred to as hosts as well. So whereas in the server example, we're accepting many clients, here we're only creating one client, one time. And that is the client that we are. And I guess actually socket is a much better name than client, because it truly represents a network socket, whereas a client is slightly different. Well, they can mean the same thing. Sorry for the confusion. Anyway, so again, I'm just going to call this variable chunk. I like to call the data variable chunk because sometimes I like to listen for lots of data and then concatenate it all together, and I call that variable data. Anyway, so if we get data from the server, we'll just print it to the screen. And I think there's also an event like that's maybe connected or something. Could probably use that event as well. Let me just see in the documentation. Connected, server connected, client connected. Oh, it's just .connect. Ah, okay. That makes sense. I could have sworn there was an event, though. I like listening on events. There is a connect event. Let's see if it works the way I think it does. So we'll say connected to the server. When we get data, we'll just print it out to the screen. And And when the connection ends, we'll say that the server hung up. Great. So now I'm back on my Linux box. I'm going to listen. This time I'll pick port 4000 because I already hard-coded it into this other one anyway. And then I just do node nc client. Okay, so I can do either. The way that I typed it is right as well. There was create connection and there's .connect, and it looks like the new way to do it. I'll do it the new way because it's probably the way I should do it, because they might remove the old way at some point. But the way that I should do it is called .connect. Both functions are actually the same thing. They just got renamed, so they left the old name in there. But anyway, and then let's see, it says the connection was refused, so I must have put the wrong address in here. Yep. 115 is my Linux machine. Keep on getting the two addresses mixed up. There. Great, we connected to the server. So hello. Oh. Same problem here. .toString UTF-8. So it knows that it should print out what it gets. So the thing with this buffer object is that JavaScript has a data type, or Node JavaScript has a data type that's called buffer, and if you log it, then what it prints out are the actual bytes instead of the characters. And the difference between the two is just like the way that it stores it in the computer's memory versus the way that you should see it when it's printed to the screen. But since Node's buffer object works for all kinds of data, it doesn't make the assumption that it's data that should be printed to the screen. Because if you remember earlier, when we put that image to the screen, it looked like garbage. And this makes a lot more sense than that garbage does, at least to a programmer, right? So anyway, let me start up the server again, because Netcat actually quits the server every time the connection's closed. Netcat only handles one connection at a time, whereas our server can handle multiple. But we're connected to the server, and then I can say hello, and then voila, the client gets it. Now, I would like to point out that we haven't made any, we haven't done anything so that if I type on the client, that it will appear over here. We don't listen for the person typing. So let's add that in real quick. We didn't put it in the server, but it makes a lot more sense to put it in the client, because the client's really uninteresting without it. So I'm going to go back to the Node docs here, and I'm going to have to look at, I happen to know it's in the process module. Let's see, where's that at? Let me do Command F. Oh, there, nope, that's not the one. Here it is. Process.standardin, that's what it is that I'm looking for. Okay. I'm just going to copy and paste this bit here to here. Oops, let me set paste on that. Actually, there's another thing that's bugging me. I need to go in my vimrc and, oops, my .vimrc, excuse me. Oh, syntax is on? Oh, that's weird. I wonder why it's not highlighting for JavaScript. Maybe I don't have Syntastic installed. Whatever. I'll just deal without the syntax highlighting for the moment. I like the pretty colors, you know, but oh well. Oh. So here's what I'll do. I'll say if not socket console.log not connected yet. This will never happen because as a human, well, actually there is a case where it could happen. but you're not going to type fast enough that you could put in a message before the network connection's complete. That's basically what I'm trying to get at there. And so I'll just change this to socket.write. And actually, let me do one better. I'm going to move this function out so that it's not possible for that to happen. That potential error case. So another quick thing after I type this out, assign listeners, or let me just call that more generically events. Call it events here too. You'll notice that I didn't require process. Unfortunately, process is included as one of the node globals. So sadness, but oh well, it's not that bad. It would be nice if it was required that you require it, but it isn't. Anyway, so if I'm not mistaken, I can actually do it just like I do on the server side, but I don't want to. I want to keep it not confusing. I don't want it to, meaning I don't want it to be confused with what happens on the server side. And now that I've got that there, I'll move this down to the bottom just because I like to have basically my action items happen after the function is assigned or declared. So I have this function declared here. We tell it it's connected to the server. We start listening for things that the user is typing. That's the standard in. And then every time there's data, we will write the data. And when the end of transmission character is sent, that control D, then we will, let me see, should I call end or close? Let me check the documentation. Okay, looks like end is the correct one. So I'll call end, and we'll just send a final message. Goodbye. When we receive data on the socket, we're logging it to the screen. If the server says goodbye, then we'll say that the server hung up. Okay, so that should be good. Let me just look at that connect callback real quick. Connection listener. What does the connection listener take? Takes nothing. Oh, so they call it client here instead of socket. Whatever. Alright, so this is the right way to do it. I'm assigning socket, listening for the connect event. When the connect event fires, I assign all of the other events, because none of the other events can fire anyway, at least not on the socket until it's connected. And then I don't want to listen on standard in until we're connected, and then once we start listening, then if somebody had typed something before, it'll pile up at that point. Okay, cool. So now node nc client, and let me get my server running again here. Hello. Nice. So there we are. And now I will go ahead and start my other server. I'm going to start it in this window. This again is on my Mac. That's interesting. I wonder why that... Oh, I know why that's still going. I need to tell it not to listen on standard in anymore once the server hangs up. So let me just try that scenario. Oh, again real quick. Start server, start client, end server, and ends client. Good. Okay. But I want to start my own Netcat server, and then I want to start my own Netcat client. Oops. I need to adjust my Netcat client. I guess while we're talking about standard in and stuff, I should just go ahead and mention process.argv is how you get arguments that are passed to your program. So let's see what I want to do here. Instead of making it always port 4000, let's make it process.argv, and then it starts at the number 2, oddly enough, because the number 0 will always be node, because node is the program running, so it's the first thing that you're typing. And then the next thing is the name of the file itself. So argv0 is node, argv1 is nclient.js. So then arg2 is whatever comes after that, and arg3 is whatever comes after that. So we'll do, actually let's reverse this, make that 3 and 2. So the address comes first and then port. So now, and we'll just have it default, we'll say or 4000. Oops. So we don't specify anything, I still get something. And then or, actually just make it or localhost. That'd be a good one to try. Anyway, so if I do nothing, then it will connect localhost on port 4000. Otherwise, I can type exactly what I want, like 0.0.118 4000, and it's still connected. So now, with my server running on my Mac, a client running on my Mac, I'll start another client here on the Linux machine. So 0.0.118 4000. So now I can see that a client joined over there. So I can type hello over here. I can type heya over here. Now I have different programs. I have Netcat, the real Netcat, and then I have my own Netcat that I wrote. So now we've got a really great system where different programs are talking to each other all over the network. So there's probably huge brain dump, but watch it again in slow motion, check it out, and of course, ask me any questions if anything's terribly unclear. But now you know how to do basic TCP. Now you should understand how a network works. That it's actually really simple. I mean, aside from you probably need a little bit more information on IP addresses or and ports to really grasp what's going on. But in terms of, I mean, it's just like reading from a file, or like there's what's happening is you just have data on one end that's going on the other end. The network isn't magic. Hopefully that's what got demystified here. So I'll leave you with that. Thanks for watching. If this was useful for you, please go ahead and give that little thumbs up button a nice click. Also, you'll see the notes are in the comments section down below. You can either at the end of the article or right up at the top. Give it a like, tweet, +1, whatever. Thanks.